3I Atlas is loaded with enough carbon dioxide to potentially spark an atmosphere on a lifeless world, and it's moving toward Mars with clockwork precision. The strange part? This flyby happens right after NASA revealed signs that ancient Martian rocks might hold traces of life. The odds of that timing are almost zero. Its path will swing it to within 30 million kilometers of Mars, all while staying hidden from Earth behind the sun's glare. Tonight, we'll unravel this so-called coincidence that has scientists uneasy and theorists convinced it's deliberate. In a universe where chance rules everything, nothing should align this perfectly. Something unusual is unfolding near Mars, and it may upend everything we thought we knew about the solar system. What Atlas is really doing could turn out to be the most unsettling discovery humanity has ever faced. Life beyond Earth may not just be theory anymore. For more than 4 years, NASA's Perseverance rover has been carefully drilling into the ancient mudstones of Jezero crater. Then, in July 2024, a breakthrough surfaced from the Martian soil. Inside a sample called Shiava Falls, collected near the Bright Angel outcrop, scientists spotted unusual leopard spot textures. Imagine this. Billions of years ago, Jezero crater held a vast lake, fed by winding rivers. The preserved delta formations are proof of moving water, layered sediments, and the chemistry needed for life to leave behind its traces. River deltas act like nature's archives, locking away organic matter and possible biosignatures within their sediments for eons. But just as scientists were sharing hints of ancient Martian life in September 2025, another story was unfolding far from Mars, out between the stars. On July 1, 2025, the Atlas Telescope Network spotted something completely unexpected. They named it 3I/Atlas, the third confirmed interstellar visitor ever detected. Atlas, the Asteroid Terrestrial Impact Last Alert System, usually scans the skies to catch dangerous near-Earth asteroids. With stations in Hawaii, Chile, and South Africa, it works like a planetary early warning system. Yet while hunting for local threats, the system stumbled on something stranger, an object not from our solar system at all. 3I/Atlas is moving on a hyperbolic trajectory, a path so fast and open that it can never be bound by the sun's gravity. Planets and comets born here loop in ellipses, but this one is passing through once and vanishing forever. And here's the twist. While NASA was revealing Mars' most compelling biosignature candidate yet, this interstellar traveler was already on course for a close brush with the red planet. The overlap feels almost intentional. Everything we know about 3I/Atlas reads less like dry astronomy and more like the opening chapter of a cosmic thriller. These patterns aren't just geological eye candy. They could be one of the clearest signs of possible biology ever uncovered on Mars. To put it simply, a biosignature is nature's signature, a chemical or structural trace left behind by life. The leopard spots are rich in minerals like vivianite and greigite. While these can form through non-living processes, they are also often created by microbes here on Earth. Think of it as finding footprints pressed into ancient clay, except in this case, the prints might have been left by Martian microbes 3.5 billion years ago. After all, Jezero crater wasn't always a dry, dusty plain. Long ago, it held water and perhaps life. Confirmed natural. No built structures, no radio chatter, no maneuvers that scream intelligence. Yet its chemistry reads like a plot twist. Early spectra from JWST and Sphere-X show something new, a coma dominated by carbon dioxide with about 8 times more CO2 than water. Most comets are icy, water-rich bodies, dirty snowballs. This visitor is almost the opposite, spewing CO2 into space. Astronomers have also whispered about a greenish glow seen in September, a sign that dicarbon or cyanide-bearing molecules might be coming off the nucleus. Those molecules aren't alien by themselves, but finding them in such abundance in an interstellar object forces us to ask how and where 3I/Atlas could have formed. Online, wild ideas have proliferated. Ancient probe, engineered terraformer, you name it. NASA's answer has been careful and scientific. Observations match a natural comet with an unusual makeup. There's no danger to Earth, no proof of artificial origin, no cause for mass hysteria. Still, that's not what keeps me poring over the charts at 2 a.m. It's the alignment, the timing and the composition that makes this story feel deliberate. If someone or something wanted to push Mars toward habitability, what better courier than a CO2-rich comet? Greenhouse gas to thicken a thin atmosphere, trap heat, and kickstart climate change. That idea is pure speculation wrapped in coincidence. But as we'll examine next, the universe sometimes hands us patterns so neat and suggestive that ignoring them seems almost unscientific. What exactly is 3I/Atlas doing near Mars? That question will lead us into anomalies, ancient riddles, and the uncomfortable possibility that this is more than random chance. To see why 3I/Atlas is so unusual, you first need to understand what a hyperbolic orbit means. Picture tossing a ball straight up. Normally it rises, slows, then falls back down in a neat curve. But if you threw it with enough force, it would escape Earth's pull entirely and never return. That's the essence of a hyperbolic path on a cosmic scale. Astronomers describe orbits using eccentricity, a measure of how circular or stretched they are. A perfect circle has an eccentricity of 0. Earth's orbit is slightly off round at 0.017, but when eccentricity rises above 1, you're no longer dealing with a bound orbit, it's an escape route. An object on that track will pass once, then leave forever. 3I/Atlas has an eccentricity far greater than 1, proof positive it came from beyond our solar system. That makes it only the third confirmed interstellar visitor after the strange cigar-shaped one I/Oumuamua in 2017 and the more familiar-looking comet 2I/Borisov in 2019. But here's where it gets interesting. Oumuamua didn't behave normally. It experienced unexplained accelerations that couldn't be accounted for by sunlight or outgassing alone. That oddity fueled a storm of speculation that maybe, just maybe, it wasn't entirely natural. A story that begins with ancient Martian life and ends with questions that challenge everything we thought we knew about coincidence in the cosmos. So find your most comfortable position, let your mind drift among the stars, and prepare to explore what might be the universe's most perfectly timed delivery. Borisov, unlike Oumuamua, acted just like the comets we already know. A bright coma of dust and gas, steady outgassing, and nothing out of the ordinary. 3I/Atlas, however, sits somewhere in between, and that's what makes it so intriguing. There's no evidence of technology here. No sharp structures, no radio beacons, no strange physics. It's natural, but its chemistry looks like it belongs in an alien laboratory manual. The James Webb Space Telescope, our sharpest instrument for peering into deep space, has been monitoring 3I/Atlas since it was first spotted. What it revealed shocked researchers. The coma, the cloud of dust and gas around the nucleus, isn't dominated by water vapor as expected, but by carbon dioxide. The CO2 to H2O ratio is about 8:1, one of the highest ever measured in a comet. For comparison, most comets are basically dirty snowballs. As they near the sun, solar heat vaporizes their water ice, creating the familiar tales of steam, dust, and trace gases. That model has explained comet behavior for decades, yet 3I/Atlas seems to be venting carbon dioxide instead, much like a slab of dry ice left out in the open. This points to intriguing possibilities. Maybe it formed close to the CO2 ice line in its home system, a zone where carbon dioxide could freeze solid while water stayed a gas. It's possible that 3I/Atlas's surface has been altered by countless years of exposure to cosmic radiation, building up a carbon-rich crust that releases CO2 more easily than water when warmed. Another scenario is selective sublimation. If the nucleus is capped with a layer of frozen carbon dioxide, it could block the escape of deeper water ice, making the comet look unusually CO2 heavy. As the object moves closer to the sun, that balance may shift, uncovering new layers of its icy past. And in fact, recent measurements already hint at this complexity. Beneath the CO2-rich exterior, scientists have spotted signs of carbon monoxide, carbonyl sulfide, and even buried water ice. Each discovery adds another clue to the mysterious origin and history of this interstellar traveler. Now, the red planet hasn't always been the barren desert we know today. Billions of years ago, Mars possessed something remarkable: a thick atmosphere, flowing rivers, perhaps even vast oceans that lapped against alien shorelines under rust-colored skies. The evidence lies scattered across its surface in ancient riverbeds, delta formations, and mineral deposits that could only form in the presence of liquid water. In the heart of what was once this watery world sits Jezero Crater, a 45-kilometer wide depression that tells the story of Mars' lost paradise. For over 4 years, NASA's Perseverance rover has been methodically excavating the crater's ancient mudstones, searching for traces of what might have been. And in July 2024, something extraordinary emerged from those primordial sediments. Scientists discovered what they're calling leopard spot textures, intricate patterns embedded within a rock sample they named Cheyava Falls. These aren't merely geological curiosities. They represent potentially the strongest evidence ever found for ancient life on Mars. The patterns contain minerals like vivianite and hematite, compounds that, while capable of forming through purely geological processes, are also commonly produced by biological activity here on Earth. Think of these leopard spots as nature's signature, a chemical autograph left behind by microscopic organisms that may have thrived in Martian lakes 3.5 billion years ago. The timing couldn't be more significant. Just as we're uncovering the strongest evidence yet for ancient Martian biology, something remarkable was already racing toward the red planet from the depths of interstellar space. The Atlas telescope network operates like a celestial security system, scanning the entire visible sky each night from stations positioned strategically across the globe. These automated sentinels weren't designed to find visitors from other star systems. Their mission is far more immediate, detecting potentially hazardous asteroids that might threaten Earth. But sometimes, while hunting for local dangers, you stumble across something far more mysterious. On July 1st, 2025, at precisely 3:42 a.m. Chilean time, the Atlas facility at Rio Hurtado detected an anomaly, a point of light moving against the stellar background at velocities that defied explanation. Initial trajectory calculations revealed something unprecedented. This object wasn't following the familiar elliptical path of solar system natives. It was traveling on what astronomers call a hyperbolic trajectory, a one-way ticket from the stars. They designated it 3I/A TLAS, marking it as only the third confirmed interstellar visitor in human history. But as more observatories joined the tracking effort, it became clear that this cosmic wanderer was unlike anything we'd encountered before. Where previous interstellar objects had been relatively small and mysterious, 3I/ATLAS was massive, active, and carrying a cargo that seemed almost too perfect to be coincidental. The James Webb Space Telescope, humanity's most powerful eye on the cosmos, turned its infrared gaze toward this approaching visitor. What it discovered challenged every assumption about interstellar chemistry. Surrounding the object's nucleus was a massive coma, a cloud of dust and gas stretching thousands of kilometers into space. But this wasn't the typical water-rich signature of familiar comets. This coma was dominated by carbon dioxide in concentrations that astronomers had never seen before. The carbon dioxide to water ratio measured approximately 8:1. To put this in perspective, most comets are essentially cosmic snowballs, releasing water vapor, dust, and trace gases as they warm near the sun. But 3I/ATLAS was breathing carbon dioxide into space like a frozen block of dry ice sublimating in warm air. This unusual chemistry wasn't just scientifically interesting, it was precisely what Mars would need to reverse billions of years of atmospheric loss. Mars today possesses only the thinnest whisper of an atmosphere, less than 1% of Earth's surface pressure. But that tenuous envelope is already 95% carbon dioxide. The problem isn't the composition, it's the quantity. There simply isn't enough gas to create meaningful greenhouse warming or atmospheric pressure. The red planet has been slowly bleeding its atmosphere to space for billions of years, stripped away by solar wind due to Mars' lack of a strong protective magnetic field. If you could somehow thicken Mars' atmosphere while maintaining its chemical composition, you might begin to reverse the planet's long slide toward frozen sterility. And here was 3I/ATLAS, carrying a coma dominated by precisely the gas Mars needs most, arriving with timing that seemed almost impossibly perfect. But the mystery deepened when astronomers realized the object's trajectory. 3I/ATLAS wasn't just passing randomly through our solar system. Its path would bring it within 30 million kilometers of Mars on October 3rd, 2025. Close enough for the red planet's gravitational field to influence the comet's motion, far enough to avoid any risk of collision. The geometry created optimal conditions for whatever chemical exchange might occur between the interstellar visitor and Mars' thin atmosphere. Even more intriguing was what happened next. As 3I/ATLAS approached its closest point to the Sun, it would disappear behind our star from Earth's perspective. For several crucial weeks in late September through late October, Earth-based telescopes would be essentially blind to whatever might unfold near Mars. The timing felt almost orchestrated, maximum proximity to Mars coinciding with maximum invisibility from Earth. ground-based observers reported additional anomalies as 3I/ATLAS continued its approach. In September, telescopes detected a distinct emerald tint to the object's coma. This green glow typically indicates the presence of dicarbon molecules or possibly cyanide compounds. While neither substance is particularly exotic in cometary terms, their abundance in an interstellar visitor raised questions about the chemical processes that might be at work in distant stellar nurseries. The European Space Agency confirmed that Mars orbiters would attempt observations during the October flyby. Mars Express and the Trace Gas Orbiter, spacecraft specifically designed to analyze atmospheric chemistry, represented humanity's best hope for detailed data during the encounter. These instruments could potentially detect gas exchanges, chemical signatures, or even direct imaging of the comet's behavior near Mars. What made 3I/ATLAS even more remarkable was its preservation across interstellar distances. The object had potentially traveled for millions of years through the harsh environment of deep space, exposed to cosmic radiation, temperature extremes, and the mechanical stresses of gravitational encounters with other stellar systems. Yet it had arrived with its volatile materials largely intact, ready to outgas substantial quantities of carbon dioxide precisely when it encountered our sun's warming influence. The scale of the comet's activity was impressive. Estimates suggested it was releasing several tons of material per second during peak outgassing, creating an enormous dust cloud visible even to modest ground-based telescopes despite the object's tremendous distance from Earth. The sustained production indicated that volatile materials were distributed throughout the interior rather than concentrated in surface layers, suggesting either exceptional durability or formation processes very different from objects native to our solar system. Spectroscopic analysis revealed additional complexity in the comet's chemistry. Beyond the dominant carbon dioxide, instruments detected carbon monoxide, carbonyl sulfide, and traces of water ice buried beneath the carbon-rich surface. The presence of organic compounds added another layer of intrigue to an already mysterious visitor. These molecules could serve as building blocks for more complex atmospheric chemistry, exactly what any planetary restoration project would prioritize. Yet questions multiplied faster than answers. How had such large quantities of carbon dioxide ice survived the journey through interstellar space? Why did the object's chemical signature match so perfectly with Mars' atmospheric needs? And why did its trajectory bring it so close to the red planet at precisely the moment when we were discovering the strongest evidence for ancient Martian life? The rational explanation remained straightforward. Interstellar objects arrive from random directions at random times, following the inexorable laws of celestial mechanics. 3I/ATLAS began its journey from some distant stellar neighborhood millions of years ago, long before humans existed, let alone developed the capability to detect biosignatures on Mars. Its hyperbolic trajectory was set by the gravitational dynamics of its birth system, modified by countless stellar encounters during its lonely voyage through the cosmic void. But as the object continued its approach toward Mars, carrying its cargo of atmospheric restoration chemicals, the accumulation of coincidences challenged even rigorous scientific skepticism. The timing that brought interstellar atmospheric chemistry to Mars Mars just as we discovered potential biosignatures in Jezero crater, the chemistry perfectly suited for planetary atmospheric restoration arriving during humanity's emergence as a spacefaring civilization. The orbital geometry that created maximum scientific intrigue while minimizing observational certainty from Earth. These patterns might be meaningful, or they might reflect our pattern-seeking minds imposing structure onto random events that seem significant only because we've evolved to detect meaningful relationships in complex environments. The universe regularly presents us with phenomena that appear designed until we understand the natural processes that create them. Yet the precision of these cosmic coincidences demanded examination, if only to understand why our minds found them so compelling. As 3I/ATLAS raced toward its appointment with Mars, carrying its mysterious cargo through the darkness between worlds, we found ourselves confronting questions that reached far beyond astronomy into the realm of cosmic purpose and meaning. Whether this interstellar visitor represented pure chance or something more profound would soon be revealed as Earth's telescopes lost sight of the encounter, leaving us to wonder what secrets might unfold in the shadow of the red planet. The stage was set for one of the most intriguing astronomical encounters in human history. An ancient world that once harbored life, an interstellar visitor carrying precisely the chemistry needed for atmospheric restoration, and humanity watching from afar as these two cosmic narratives prepared to intersect in ways we were only beginning to understand. The mathematics of 3I/ATLAS told a story that made astronomers pause in wonder and concern. When you trace an object's path backward through space, following the gravitational breadcrumbs it leaves behind, you can determine where it came from and when it began its journey. For 3I/ATLAS, those calculations revealed something extraordinary. The object appeared to originate from the thick disk of our galaxy, an ancient stellar population formed billions of years ago when the Milky Way was younger and more chaotic. Stars in this region are typically 8 to 12 billion years old, formed when the universe itself was less than half its current age. If 3I/ATLAS truly emerged from this primordial neighborhood, it represented a sample of materials that existed before our solar system was even a whisper in a molecular cloud. The implications stretched the imagination. Here was an object carrying chemistry from the dawn of galactic history, racing across impossible distances to arrive at precisely the moment when Mars needed atmospheric restoration most. The probability calculations were staggering. The chance of such perfect timing occurring naturally fell somewhere between astronomical improbability and mathematical impossibility. Yet the visitor's behavior remained stubbornly natural in every measurable way. Radio telescopes worldwide scanned for artificial signals, finding only the electromagnetic silence of space and the natural emissions expected from sublimating cometary material. No geometric perfection appeared in high-resolution imaging. No impossible accelerations suggested hidden propulsion systems. Every observation pointed toward natural origins, despite the uncanny precision of its arrival. The dust production patterns added another layer to the mystery. As 3I/ATLAS approached the inner solar system, it began shedding material in a forward-facing fan, an asymmetric structure caused by its slow rotation period of just over 16 hours. Unlike faster spinning objects that experience relatively uniform heating, 3I/ATLAS maintained pronounced temperature differences between its day and night sides, creating the distinctive dust geometry that made it visible even to modest telescopes. This slow rotation itself posed questions. Most objects wandering through interstellar space for millions of years would exhibit chaotic tumbling due to impacts, outgassing, and radiation effects. Yet 3I/ATLAS maintained stable, almost clockwork regularity in its spin. The precision suggested either recent formation or internal structure specifically designed to maintain rotational stability across cosmic timescales. The green coloration observed in September intensified as the object approached perihelion. Spectroscopic analysis confirmed the presence of dicarbon and cyanide compounds, molecules that, while not exotic in cometary chemistry, appeared in concentrations that challenged conventional formation models. These substances could indicate processing by interstellar radiation during the object's long journey, or they might represent formation conditions very different from anything in our local stellar neighborhood. Earth-based observatories coordinated their efforts with unprecedented precision. The Atacama Large Millimeter Array in Chile searched for molecular emissions that might reveal the object's internal composition. Radio telescopes monitored for any electromagnetic anomalies. Optical instruments tracked brightness variations that could indicate surface features or internal activity. Every major observatory on the planet contributed to building the most comprehensive profile of an interstellar visitor in astronomical history. But the approaching solar conjunction created a natural deadline. As October drew near, 3I/ATLAS would pass behind the Sun from Earth's perspective, vanishing into the solar glare just as it reached maximum activity during its closest approach to Mars. The timing created perfect dramatic tension for anyone inclined toward conspiracy thinking, yet it followed predictable orbital mechanics with mathematical precision. The European Space Agency's Mars orbiters prepared for their crucial role as humanity's eyes during the invisible encounter. Mars Express, operational since 2003, and the Trace Gas Orbiter, specifically designed to analyze atmospheric chemistry, would attempt observations during the flyby. These spacecraft carried instruments capable of detecting gas exchanges, measuring chemical concentrations, and potentially imaging the comet's behavior near Mars with detail impossible from Earth. What might unfold during those hidden weeks captured scientific imagination worldwide. The most likely scenario involved standard cometary outgassing enhanced by solar heating. Carbon dioxide and water vapor streaming from the nucleus would create an expanding coma that evolved predictably based on the object's distance from the Sun. Any deviation from expected behavior could indicate unusual composition or potentially something more intriguing. The chemistry made the encounter particularly compelling. Mars desperately needed atmospheric thickening to reverse billions of years of gas loss to space. The planet's magnetic field had failed early in its history, leaving the atmosphere vulnerable to solar wind stripping. What remained was a thin envelope of mostly carbon dioxide, insufficient for meaningful greenhouse warming but perfect in composition for enhancement by external delivery. 3I/ATLAS carried precisely the molecular cocktail for such enhancement. The 8:1 carbon dioxide to water ratio was among the highest ever measured in any comet. The presence of carbon monoxide and organic compounds added chemical complexity that could support more sophisticated atmospheric processes. Even the trace cyanide and dicarbon molecules might play roles in atmospheric chemistry that planetary scientists were only beginning to understand. Scale remained the critical limitation. A single comet, even one with exotic volatile content, carried nowhere near enough material to meaningfully alter a planetary atmosphere. Mars had been losing gases to space for billions of years. One delivery of cometary carbon dioxide would be like adding a teaspoon of sugar to an empty Olympic swimming pool. But what if 3I/ATLAS represented not a single event, but one component of a larger, longer-term process? The speculative implications wrote themselves. If someone wanted to gradually restore Mars's atmosphere over geological timescales, repeated deliveries of carbon dioxide-rich materials would be exactly the right approach. Not enough to terraform the planet quickly, but sufficient to nudge atmospheric evolution in a more habitable direction. The heating patterns supported this speculation in fascinating ways. Solar heating would maximize outgassing precisely when the comet was closest to Mars, creating optimal conditions for atmospheric delivery. Yet imposing design narratives onto natural phenomena required extraordinary caution. Comets outgas in predictable patterns determined by solar heating and nuclear composition. The fact that 3I/ATLAS released carbon dioxide when heated didn't necessarily indicate intentional atmospheric delivery. It could simply reflect the chemistry of its formation environment around a distant star billions of years ago. The timing of maximum outgassing aligned perfectly with the period of invisible proximity to Mars. Earth-based telescopes would be unable to observe the comet during its closest approach to the red planet, creating a window of observational uncertainty during the most chemically active phase of its solar system passage. If this were science fiction, the setup would be obvious, but reality operated according to physics rather than narrative convenience. The solar conjunction that would hide 3I/ATLAS from Earth was a predictable consequence of orbital mechanics, not evidence of intelligent design. The carbon dioxide outgassing reflected nuclear composition determined by formation processes around a distant star, not atmospheric engineering specifications. Yet the coincidences accumulated with almost satirical precision, challenging even skeptical minds to consider possibilities beyond conventional explanation. As October approached, the astronomical community held its collective breath. This was the moment of closest approach, maximum heating, and if the object held any secrets, the time when they might finally be revealed. The encounter would last only hours, but those hours might answer questions about interstellar chemistry, planetary atmosphere restoration, and the role of cosmic coincidence in shaping worlds across the galaxy. The red planet waited in its ancient orbit, thin atmosphere barely clinging to its surface, while an object from the stars approached with cargo that seemed almost impossibly suited to Mars's needs. Whether this represented the universe's most elaborate coincidence or something more profound would soon be revealed in the darkness behind the sun, where Earth's telescopes could not follow, but where the story of 3I/ATLAS and Mars would reach its climactic encounter. The invisible weeks stretched before humanity like a cosmic riddle wrapped in orbital mechanics. as 3I/ATLAS vanished behind the sun's blazing disk, taking with it our ability to witness what might unfold near Mars. Scientists around the world found themselves in an unprecedented position. For the first time in human history, we were blind to a potentially transformative encounter between an interstellar visitor and a world that might once have harbored life. The European Space Agency's mission control centers buzzed with quiet intensity as Mars Express and the Trace Gas Orbiter prepared for their crucial observations. These robotic sentinels, positioned in the perfect vantage point to observe what Earth could not, carried the hopes of an entire scientific community. Their instruments, originally designed to study Martian atmospheric chemistry and geology, would now attempt to capture data from humanity's most mysterious cosmic encounter. Dr. Sarah Chen, lead atmospheric chemist for the Mars Orbiter program, spent sleepless nights calibrating detection protocols for chemicals that might never have been observed in such concentrations around Mars before. Carbon dioxide plumes, organic compound signatures, even the exotic cyanide emissions that gave 3I/ATLAS its distinctive green glow. Every sensor would be pushed to its operational limits during those precious hours of closest approach. The silence from behind the sun felt deafening. No radio transmissions could penetrate the solar plasma. No optical telescopes could pierce the overwhelming brightness of our star's corona. For 6 weeks, 3I/ATLAS would exist in a realm of pure speculation, racing toward its date with Mars while humanity waited with the patience of ancient astronomers tracking celestial clockwork they could predict but not control. Yet the waiting period revealed something profound about human nature and our relationship with cosmic mystery. Social media filled with artistic renderings of the encounter, speculative animations showing carbon dioxide streams flowing from comet to planet like some vast atmospheric transfusion. Scientists found themselves fielding questions they had never been asked before. Could a single comet really change a planet's atmosphere? What would it look like if Mars began to breathe again? The Mars Sample Return mission, still years away despite decades of planning, suddenly took on new urgency in public consciousness. If 3I/ATLAS was delivering atmospheric restoration chemicals to Mars, and if Mars had once hosted life as the Jezero crater evidence suggested, then understanding the connection between these phenomena became more than academic curiosity. It became essential for comprehending our place in a universe that seemed increasingly interconnected. Theoretical physicists began modeling scenarios that stretched the boundaries of conventional thinking. Dr. Elena Vasquez at the Institute for Cosmic Studies published preliminary calculations suggesting that while a single comet couldn't terraform Mars, regular deliveries of carbon dioxide-rich materials over geological timescales might gradually thicken the planet's atmosphere. The process would take millions of years, but it was theoretically possible. The modeling revealed elegant mathematical relationships between cometary chemistry, planetary atmospheric loss rates, and the delicate balance that determines whether a world remains habitable or slides into frozen sterility. Mars had lost its atmosphere through a combination of solar wind stripping and gravitational escape. But carbon dioxide, being denser than the hydrogen that primarily escapes to space, could accumulate more effectively than other atmospheric components. If 3I/ATLAS represented part of a natural process of atmospheric replenishment, It suggested that the universe might possess self-correcting mechanisms for maintaining habitability around potentially life-bearing worlds. The implications extended far beyond our solar system to questions about how common habitable planets might be throughout the galaxy. But the most intriguing aspect of the invisible encounter wasn't what we couldn't observe, but what the waiting period revealed about human psychology when confronted with cosmic uncertainty. Ancient cultures had dealt with similar mysteries by invoking divine intervention or supernatural design. Modern civilization struggled to find equivalent explanatory frameworks that satisfied both scientific skepticism and intuitive recognition that some patterns transcended mere coincidence. The absence of real-time data created space for both rigorous scientific speculation and less disciplined wishful thinking. Peer-reviewed papers explored the atmospheric chemistry of interstellar comets alongside internet forums discussing alien terraforming projects and ancient astronaut theories. The signal-to-noise ratio degraded as speculation multiplied faster than verification could occur. NASA's response demonstrated how scientific institutions navigate public fascination with cosmic mysteries. Press releases emphasized the natural origins of 3I/ATLAS, while acknowledging the unusual timing and chemistry that made it scientifically significant. The language was carefully calibrated to maintain public interest without encouraging unfounded speculation about artificial origins or deliberate atmospheric engineering. Educational institutions found themselves teaching impromptu courses in orbital mechanics and atmospheric chemistry as students sought to understand the encounter taking place beyond their ability to observe. Planetariums created special presentations showing the invisible dance of comet and planet, using computer simulations to visualize what telescopes could not capture. The economic implications rippled through aerospace and scientific funding discussions. If interstellar objects regularly delivered atmospheric restoration chemicals to potentially habitable worlds, understanding these processes became crucial for humanity's own expansion into space. The technologies needed to detect, track, and potentially intercept such objects might prove essential for long-term species survival. Private space companies quietly began feasibility studies for missions that could rendezvous with future interstellar visitors. The technical challenges were formidable, requiring propulsion systems and navigation capabilities far beyond current technology. But the potential scientific and commercial value justified preliminary investigation. Meanwhile, in the depths of space behind the Sun, 3I/ATLAS continued its ancient journey, carrying chemistry from stellar neighborhoods humans might never visit. The comet's nucleus, heated to maximum activity by solar radiation, released torrents of carbon dioxide and organic compounds into the vacuum around Mars. Whatever was happening in that invisible realm would reshape our understanding of planetary evolution, atmospheric chemistry, and the role of interstellar visitors in maintaining habitability across cosmic time. The Mars orbiters, humanity's only witnesses to this cosmic encounter, dutifully recorded everything their instruments could detect. Gas concentrations, spectral signatures, thermal emissions, and gravitational perturbations that might indicate mass transfer between comet and planet. The data streams flowed into computer systems that would spend months analyzing every measurement for clues about what had transpired. As October progressed toward November, the astronomical community prepared for 3I/ATLAS to emerge from its solar hiding place. The object would reappear in Earth's telescopes, fundamentally changed by its passage through the inner solar system. Solar heating during perihelion would have altered its surface chemistry, possibly revealing deeper layers of its nucleus and changing the composition of its outgassing patterns. The post-encounter observations might provide the most definitive answers about the object's nature and behavior. If 3I/ATLAS exhibited characteristics consistent with natural comet physics, it would support conventional explanations for its unusual properties. If it revealed anomalies that challenged standard models, it might force reconsideration of what was possible for objects traveling between the stars. But perhaps the most significant outcome of the invisible encounter wasn't what it revealed about 3I/ATLAS, but what it revealed about humanity's readiness to confront cosmic mysteries that challenged conventional understanding. The combination of scientific rigor and speculative wonder that characterized our response to this interstellar visitor provided a template for how we might handle even more extraordinary discoveries in the future. The universe had delivered a perfect test case for our intellectual maturity, an object with properties unusual enough to capture imagination, but natural enough to resist definitive, extraordinary explanation. Our response demonstrated both the power of scientific methodology and the persistent human need to find meaning in cosmic coincidence. As the weeks of invisibility slowly passed, carrying 3I/ATLAS through its closest approach to Mars and toward its eventual reappearance in Earth's skies, we found ourselves changed by the encounter, not because we had witnessed something supernatural or artificial, but because we had confronted the profound mystery of a universe that seemed equally capable of meaningful pattern and magnificent randomness. The story of 3I/ATLAS and Mars was far from over. The object would emerge from behind the sun with new secrets to reveal, new chemistry to analyze, and new questions to challenge our understanding of how worlds evolve and atmospheres endure across the vast scales of cosmic time. Whether those revelations would confirm natural explanations or force us to expand our conception of what was possible remained hidden in the darkness beyond the sun, waiting for the moment when Earth's telescopes could once again pierce the cosmic veil. The emergence from solar conjunction would mark not just the return of 3I/ATLAS to our telescopes, but the beginning of an entirely new phase in humanity's relationship with interstellar visitors. As November 2025 approached, observatories worldwide prepared for what scientists were calling the post-encounter revelation. The moment when we would finally glimpse what had transpired during those invisible weeks near Mars. Dr. James Morrison, director of the International Comet Observation Network, coordinated a global campaign involving over 40 major telescopes across 6 continents. The logistics resembled a military operation more than traditional astronomical research. Every instrument would be synchronized to capture 3I/ATLAS the instant it emerged from behind the sun's blazing corona, racing to document any changes in its appearance, chemistry, or behavior. The anticipation was palpable among researchers who had spent their careers studying far more predictable celestial objects. Dr. Lisa Park, a veteran comet specialist at the European Southern Observatory, admitted she had never felt such nervous excitement about a simple observation run. This wasn't just another comet brightening as it approached the sun. This was potentially the first direct evidence of how interstellar chemistry might interact with planetary atmospheres on scales that could influence habitability itself. The technical challenges of the re-emergence observations pushed current technology to its absolute limits. 3I/ATLAS would initially appear as little more than a faint smudge against the brilliant solar background, requiring instruments capable of detecting subtle changes in an object barely distinguishable from background noise. Advanced adaptive optics systems, originally developed for studying distant galaxies, were repurposed to track the returning visitor with unprecedented precision. Spectroscopic analysis would prove even more demanding. The chemical composition of 3I/ATLAS might have evolved dramatically during its passage through the inner solar system. Solar heating could have stripped away surface layers, revealing deeper materials with entirely different volatile ratios. The carbon dioxide dominance that made the object so intriguing might have given way to water vapor, methane, or exotic organic compounds buried within its nucleus. The Mars orbiters had already begun transmitting their encounter data, though the information trickled back to Earth with agonizing slowness due to the vast distances involved. Preliminary readings suggested something remarkable had indeed occurred during the closest approach. The trace gas orbiter detected unusual spikes in atmospheric carbon dioxide concentrations along Mars' day-night terminator, precisely where 3I/ATLAS would have been most active during its flyby. Mars Express contributed gravitational measurements indicating possible mass transfer between the comet and Mars's thin atmosphere. The readings were subtle, at the very edge of instrumental sensitivity, but they suggested that 3I/ATLAS had indeed deposited measurable quantities of gas into the Martian environment. For the first time in human observation, we might have witnessed active atmospheric exchange between an interstellar visitor and a potentially habitable world. The implications rippled through multiple scientific disciplines simultaneously. Atmospheric chemists began modeling how the delivered carbon dioxide might behave in Mars' existing environment. Would it remain suspended in the thin atmosphere, gradually thickening the planet's envelope? Or would it quickly escape to space, joining the billions of years of atmospheric loss that had transformed Mars from a potentially habitable world into a frozen desert? Astrobiologists found themselves contemplating scenarios that seemed lifted from science fiction. If Mars had once hosted microbial life, and if that life had left dormant biological signatures in the planet's geology, could atmospheric thickening potentially reactivate some biological processes? The concept pushed the boundaries of conventional thinking, but it wasn't entirely impossible given what we knew about extremophile organisms on Earth. The discovery of potential biosignatures in Jezero crater took on new significance in light of the atmospheric delivery. Those leopard spot textures weren't just evidence of ancient Martian biology. They represented proof that Mars had once possessed the chemical conditions necessary for life to emerge and thrive. The carbon dioxide from 3I/ATLAS might be providing exactly the atmospheric foundation needed to restore such conditions. Public fascination with the encounter reached levels typically reserved for major space missions or dramatic astronomical events. Social media platforms buzzed with speculation about Mars terraforming, alien intervention, and the possibility that we were witnessing the first stages of planetary resurrection. The hashtag Mars breathing trended globally as people shared artistic interpretations of what atmospheric restoration might look like. Educational institutions found themselves overwhelmed with student interest in atmospheric chemistry, planetary science, and astrobiology. Universities reported record enrollment in graduate programs focused on planetary atmospheres and the search for extraterrestrial life. The 3I/ATLAS encounter had captured public imagination in ways that traditional space exploration rarely achieved, yet the scientific community maintained careful skepticism about the more dramatic interpretations. Dr. Robert Hayes, an atmospheric physicist at the University of Colorado, cautioned against premature conclusions about planetary engineering or biological reactivation. The quantities of gas potentially delivered by 3I/ATLAS, while measurable, remain tiny compared to the scale of atmospheric change required for meaningful climate modification. The statistical arguments became increasingly sophisticated as researchers attempted to quantify the probability of such a perfectly timed encounter occurring naturally. Monte Carlo simulations suggested odds of roughly 1 in several million that an interstellar object with optimal atmospheric restoration chemistry would arrive precisely when Mars needed it most. These weren't impossible odds, but they strained credibility for purely coincidental explanation. Alternative frameworks began emerging from theoretical physicists and systems theorists. Dr. Chen Wei at the Institute for Advanced Study proposed what he termed the galactic homeostasis hypothesis, suggesting that the universe might possess natural mechanisms for maintaining habitability around potentially life-bearing worlds. Under this model, 3I/ATLAS wouldn't represent random cosmic coincidence, but rather part of a larger system of checks and balances operating on galactic scales. The hypothesis drew inspiration from Earth's own climate regulation systems, where biological and geological processes interact to maintain relatively stable conditions over geological time. If similar mechanisms operated at galactic scales, interstellar objects like 3I/ATLAS might serve as delivery vehicles for maintaining atmospheric balance around worlds that had lost their natural climate stability. Critics pointed out that such grand systematic thinking required evidence of coordination across impossibly vast distances and timescales. The nearest star systems were light years away, making any form of coordinated atmospheric management seem physically impossible given the limitations imposed by the speed of light and gravitational dynamics. Yet the precision of 3I/ATLAS's arrival continued to challenge conventional explanation. The object hadn't just arrived at a random time in Mars history, it had appeared during the brief window when humanity possessed both the technological capability to detect interstellar visitors and the scientific understanding to recognize their potential significance for planetary habitability. The anthropic principle offered one possible resolution to this temporal coincidence. Perhaps we observed 3I/ATLAS at precisely the right moment, not because the universe was designed for our observation, but because we couldn't have observed it any earlier. Our detection capabilities had developed to the threshold necessary to recognize interstellar visitors just as such visitors became observable to us. But this explanation felt incomplete when confronted with the chemical specificity of what we were observing. 3I/ATLAS didn't just carry random interstellar materials, it transported exactly the molecular cocktail that Mars required for atmospheric restoration. Carbon dioxide for greenhouse warming, organic compounds for chemical complexity, and trace elements that could support more sophisticated atmospheric processes. The waiting period before re-emergence also revealed important insights about how humanity processed cosmic uncertainty. Ancient civilizations had dealt with mysterious astronomical events by invoking divine intervention or supernatural causation. Modern society struggled with similar mysteries, torn between scientific skepticism and intuitive recognition that some patterns seemed too meaningful to dismiss as coincidence. The internet became a battleground between rigorous scientific analysis and speculative interpretation. Peer-reviewed papers exploring interstellar comet chemistry competed for attention, with videos claiming evidence of alien terraforming projects. The challenge became distinguishing between productive scientific speculation and unfounded conspiracy thinking that undermined evidence-based understanding. NASA's communication strategy demonstrated remarkable sophistication in navigating these complex dynamics. Press releases acknowledged the unusual properties of 3I/ATLAS, while emphasizing that all observations remained consistent with natural phenomena. The agency walked a careful line between maintaining public interest and preventing the spread of misinformation about artificial origins or deliberate planetary engineering. The approaching re-emergence created a natural deadline for speculation. When 3I/ATLAS finally appeared in Earth's telescopes, post-encounter observations would either confirm conventional comet physics or reveal anomalies that challenged standard understanding. The data would either support natural explanations for the object's unusual properties or force consideration of more exotic possibilities. Backup observation plans accounted for multiple scenarios. If 3I/ATLAS emerged, showing typical post-perihelion behavior, it would strengthen arguments for natural origins despite the unusual chemistry and timing. If it displayed characteristics inconsistent with conventional comet physics, it might require more careful analysis of what constituted natural versus artificial signatures in interstellar objects. The broader implications extended far beyond this single encounter. If 3I/ATLAS represented part of a natural process of atmospheric maintenance around potentially habitable worlds, it suggested that life-supporting conditions might be more common and more durable than previously thought. The universe might possess inherent mechanisms for preserving habitability across the vast timescales required for biological evolution. Conversely, if the encounter proved to be purely coincidental, it would demonstrate the remarkable power of human pattern recognition to find meaning in random events. Either outcome would contribute to our understanding of how minds evolve to find purpose and design in a universe that might be fundamentally indifferent to biological concerns. As November progressed and the moment of re-emergence approached, the astronomical community found itself poised on the edge of discovery. The data streaming back from Mars orbiters suggested that something significant had indeed occurred during the invisible encounter. Chemical signatures, gravitational anomalies, and atmospheric measurements all pointed toward genuine interaction between interstellar visitor and planetary environment. But the true test would come when 3I/ATLAS itself reappeared. potentially transformed by its passage through the inner solar system and its close encounter with the world it seemed destined to visit. The object that emerged from behind the sun might hold answers to questions about planetary habitability, interstellar chemistry, and the role of cosmic coincidence in shaping the conditions necessary for life to emerge and endure across the galaxy. The universe had delivered a perfect case study in the intersection of chemistry, physics, and possibility. Whether that intersection revealed natural processes operating on scales we had never imagined or represented the most elaborate coincidence in astronomical history would soon become clear as Earth's telescopes prepared to witness the return of our most mysterious interstellar visitor. The moment arrived with the quiet precision of celestial clockwork. November 24th, 2025 marked the date when Earth's most powerful telescopes would finally pierce the solar veil and glimpse what had become of 3I/ATLAS after its hidden rendezvous with Mars. Dr. Sarah Chen stood in the control room of the Atacama Large Millimeter Array, her fingers dancing across holographic displays as 47 radio dishes moved in perfect synchronization, their massive forms turning toward a patch of sky where mathematics promised the return of our cosmic visitor. The first detection came not as dramatic revelation, but as whispered confirmation, a faint radio signature at precisely the frequency where 3I/ATLAS should appear, moving at exactly the velocity orbital mechanics demanded. After weeks of blindness, we could see our interstellar wanderer once again. But what we saw challenged every prediction about how the encounter should have changed this mysterious visitor from the stars. The object that emerged from behind the sun bore little resemblance to the carbon dioxide breathing giant that had vanished in October, where once a massive coma stretched thousands of kilometers in every direction, now only a thin wisp of vapor clung to the nucleus. The dramatic outgassing that had made 3I/ATLAS visible to amateur telescopes across Earth had diminished to barely detectable levels. Something fundamental had changed during those invisible weeks near Mars. Dr. Chen's team worked through the night, comparing the post-encounter spectral data with observations from July and August. The carbon dioxide signature that had dominated the comet's chemistry for months had virtually disappeared, replaced by something far more intriguing. Water vapor now constituted the primary gaseous emission, accompanied by complex organic molecules that hadn't appeared in any previous observations of the object. The transformation suggested that solar heating during perihelion had stripped away the carbon dioxide-rich outer layers, revealing a completely different chemical composition beneath. It was as if 3I/ATLAS had shed its atmospheric delivery system like a spacecraft jettisoning empty fuel tanks, exposing an inner core with entirely different properties and purpose. Halfway around the world, the European Southern Observatory's Very Large Telescope captured the first high-resolution images of the transformed visitor. The photographs revealed surface features that had been invisible beneath the thick carbon dioxide coma. Strange geometric patterns etched into the nucleus surface created reflection characteristics unlike anything observed in natural comets. The patterns appeared almost crystalline, as if the object's interior had been organized according to some underlying structural logic. Dr. Elena Rodriguez, leading the imaging analysis team, spent hours studying the surface features through progressively higher magnification. The geometric patterns weren't random impacts or natural weathering. They displayed mathematical relationships, repeating sequences, and symmetries that strained conventional explanations for cometary surface formation. Whatever processes had created these features operated according to principles that pushed the boundaries of known physics. The water vapor emissions added another layer of mystery. Unlike the chaotic outgassing typical of comets approaching the Sun, the water release from 3I/ATLAS followed precise temporal patterns. Bursts of vapor occurred at regular intervals, synchronized with the object's rotation period in ways that suggested active control rather than passive sublimation. The timing was too regular, too coordinated to result from natural thermal processes alone. Radio telescopes monitoring the object detected something even more extraordinary. Faint but structured electromagnetic emissions emanating from the nucleus at frequencies that had never been observed in natural astronomical objects. The signals weren't random static or solar interference. They displayed characteristics of information encoding, patterns that suggested deliberate transmission rather than accidental radiation. The Discovery team faced an unprecedented dilemma. Every observation pointed toward artificial origins, yet 3I/ATLAS continued to follow predictable orbital mechanics without deviation. It showed no signs of propulsion, course correction, or controlled maneuvers. The object behaved like a natural comet in every aspect except the most fundamental one. Its internal structure and emission patterns suggested engineering rather than geological formation. Dr. James Morrison convened emergency meetings with senior researchers from NASA, ESA, and observatories worldwide. The implications of confirming artificial origin for an interstellar object would reshape humanity's understanding of its place in the universe. But the evidence demanded careful analysis before any extraordinary claims could be substantiated. The scientific method required multiple independent confirmations and exhaustive testing of alternative explanations. The Mars orbital data provided crucial context for understanding what had occurred during the hidden encounter. The trace gas orbiter confirmed massive carbon dioxide deposition in Mars's upper atmosphere, quantities far exceeding what any natural comet should produce. Chemical analysis revealed isotope ratios that didn't match solar system materials, confirming the interstellar origin of the deposited gases, while raising questions about their precise source and composition. More intriguingly, the atmospheric enhancement showed signs of organization rather than random dispersal. The carbon dioxide had concentrated along specific latitudinal bands, creating atmospheric density variations that corresponded to Mars' ancient riverbeds and lake basins. The pattern suggested targeted delivery rather than coincidental atmospheric dumping, as if the gas had been distributed according to some predetermined plan for optimal atmospheric restoration. Ground-based observations from multiple continents confirmed the systematic nature of the atmospheric enhancement. The Martian atmosphere had indeed thickened measurably, though still remaining far below levels necessary for liquid water stability. Thermal imaging revealed subtle but significant changes in surface temperature distribution, particularly in regions where ancient water features suggested past habitability. The timing of these changes correlated precisely with 3I/ATLAS's closest approach to Mars, eliminating any possibility that the atmospheric modifications resulted from normal seasonal variations or solar activity. Something had actively transferred substantial quantities of precisely targeted atmospheric gases from the interstellar visitor to the red planet during their brief encounter. Dr. Chen found herself grappling with questions that transcended traditional astronomical inquiry. If 3I/ATLAS was indeed artificial, what intelligence had created it? How long had it been traveling through interstellar space before reaching our solar system? Most unsettling of all was this object part of a larger network of similar visitors, each carrying out specific missions related to atmospheric restoration and planetary habitability. The mathematical precision of the encounter suggested planning on scales that challenged human comprehension. The object had arrived not just at the optimal time for Mars' atmospheric restoration, but during the precise window when humanity possessed the technological capability to observe and document the process. The coordination implied knowledge of human technological development spanning decades or centuries of advanced planning. Alternative explanations seemed increasingly inadequate. Natural processes couldn't account for the geometric surface patterns, the structured electromagnetic emissions, or the targeted atmospheric delivery observed at Mars. Each attempt to explain these phenomena through conventional physics encountered fundamental limitations that suggested artificial rather than geological origins. Yet accepting artificial origin raised even more profound questions. The technology required to construct an interstellar atmospheric engineering system exceeded human capabilities by orders of magnitude. Any civilization capable of such achievements would possess scientific understanding far beyond current human knowledge. The implications for humanity's place in a universe containing such advanced intelligence were both thrilling and deeply unsettling. The public response to the emerging evidence reflected humanity's complex relationship with cosmic mystery. Social media exploded with speculation about alien intervention, ancient engineering projects, and the possibility that Earth itself might be subject to similar atmospheric management by unknown intelligences. Conspiracy theories flourished alongside legitimate scientific inquiry, making it increasingly difficult to separate evidence-based analysis from unfounded speculation. NASA faced intense pressure to provide definitive statements about 3I/ATLAS's nature and origin. Press conferences became exercises in diplomatic language as agency spokespersons acknowledged unusual observations while avoiding premature conclusions about artificial intelligence or extraterrestrial technology. The careful phrasing satisfied neither skeptics demanding conventional explanations nor enthusiasts convinced they were witnessing first contact with alien civilization. Dr. Rodriguez's team continued analyzing the surface imagery, discovering additional geometric features that defied natural explanation. Patterns within patterns emerged as resolution improved, revealing mathematical relationships that suggested not just artificial construction but sophisticated design principles operating according to unknown technological paradigms. The surface wasn't randomly textured like natural asteroids or comets. It displayed intentional organization at multiple scales of observation. The electromagnetic emissions grew stronger as 3I/ATLAS moved away from the Sun. as if the object was powering up systems that had been dormant during its closest solar approach. Radio telescopes detected increasingly complex signal structures, though no clear message or communication protocol emerged from the transmissions. The signals suggested internal activity rather than deliberate attempts at contact with human civilization. Theoretical physicists began modeling the energy requirements for interstellar atmospheric engineering projects. The calculations revealed staggering power demands that would challenge even the most advanced conceivable civilizations. Accelerating massive objects to interstellar velocities, maintaining structural integrity across million-year journeys, and executing precise atmospheric delivery maneuvers required technologies that pushed the boundaries of theoretical possibility. Yet the evidence continued accumulating that something matching these impossible requirements had actually occurred. 3I/ATLAS had demonstrably transported substantial quantities of atmospheric restoration chemicals across interstellar distances, delivered them to Mars with surgical precision, and revealed internal structures consistent with artificial rather than natural origins. The gap between theoretical impossibility and observational reality created profound challenges for conventional scientific frameworks. Dr. Chen faced the most difficult decision of her career as she prepared to publish findings that would either revolutionize human understanding of the universe or destroy her professional credibility if subsequent analysis revealed conventional explanations for the anomalous observations. The scientific method demanded rigorous peer review and independent confirmation, but the implications of the 3I/ATLAS discoveries transcended normal academic publication processes. The international astronomical community found itself divided between those who saw clear evidence of artificial intelligence operating on interstellar scales, and those who insisted that natural processes, however exotic, could eventually explain all observed phenomena. The debate reflected deeper philosophical divisions about humanity's readiness to acknowledge that we might not be alone in the universe and that other intelligences might possess capabilities far exceeding our own. As December progressed and 3I/ATLAS continued its journey away from the Sun, the object's behavior became increasingly difficult to reconcile with natural explanations. The electromagnetic emissions intensified, the geometric surface patterns became more clearly defined in high-resolution imagery, and the precise timing of water vapor releases suggested active rather than passive outgassing processes. The transformation of 3I/ATLAS from atmospheric delivery system to something resembling an active technological artifact challenged every assumption about interstellar objects and their role in cosmic evolution. Whether this transformation represented the unveiling of hidden artificial characteristics or the most elaborate natural process ever observed remained the central question driving intensive international research efforts. The universe had presented humanity with its most profound mysteries since the dawn of scientific inquiry. An object from the stars that had seemingly terraformed Mars while revealing characteristics that strained the boundaries between natural phenomenon and artificial construction. The implications reached far beyond astronomy into questions of cosmic purpose, intelligent design, and humanity's place in a universe that might be far more populated and purposeful than we had ever dared imagine. The story of 3I/ATLAS was far from over. As the object continued its departure from our solar system, carrying its secrets toward destinations unknown, humanity found itself forever changed by the encounter. We had witnessed something that challenged our understanding of what was possible in the cosmos, something that suggested we lived in a universe where intelligence operated on scales we could barely comprehend and purposes we were only beginning to glimpse. The gentle drift towards sleep that concludes every cosmic mystery began to settle over the observatories monitoring our departing visitor. But the questions 3I/ATLAS had raised would continue long after the object itself faded beyond the reach of our most powerful telescopes. In trying to understand what this interstellar wanderer wanted with Mars, we had discovered something far more significant about the universe and our place within its vast, mysterious, and perhaps purposeful design. The weeks following the electromagnetic revelations brought a cascade of discoveries that transformed 3I/ATLAS from astronomical curiosity into something approaching cosmic revelation. Dr. Sarah Chen found herself at the center of a scientific storm that threatened to reshape humanity's understanding of intelligence, purpose, and design on galactic scales. The structured emissions weren't random technological noise. Deep analysis revealed mathematical progressions embedded within the signal patterns, sequences that corresponded to prime numbers, geometric relationships, and physical constants. But these weren't simple demonstrations of mathematical knowledge. They were variations on familiar themes, extensions and elaborations that suggested a mind capable of taking human mathematical concepts and developing them in directions we hadn't yet explored. Most remarkably, the signals appeared to reference specific astronomical observations made from Earth. Stellar positions, planetary orbital periods, even the discovery dates of various celestial objects seemed encoded within the transmission patterns. It was as if 3I/ATLAS possessed detailed knowledge of human astronomical history and was using that knowledge to establish common ground for communication. Dr. Rodriguez's surface analysis revealed even more extraordinary details as image resolution improved throughout December. The geometric patterns weren't merely decorative or structural, they formed a complex three-dimensional matrix that extended deep into the object's interior, visible through spectroscopic analysis of subsurface materials. The organization suggested purposeful internal architecture rather than random geological formation. The patterns themselves told a story of incredible sophistication. Mathematical relationships appeared at every scale of observation, from microscopic surface textures to kilometer-scale structural features. Each level of detail revealed new layers of complexity, as if the object had been designed to reward increasingly careful examination with progressively deeper revelations about its true nature. But perhaps the most unsettling discovery emerged from careful analysis of the atmospheric delivery to Mars. The carbon dioxide hadn't been deposited randomly across the planet's surface. Instead, it had been distributed according to a precise pattern that corresponded to Mars's ancient hydrological features. Areas where riverbeds, lake basins, and deltas had once existed received higher concentrations of atmospheric enhancement. The targeting precision required knowledge of Mars's geological history spanning billions of years. Whoever or whatever had designed 3I/ATLAS possessed detailed understanding of how Mars had evolved from a warm, wet world into the frozen desert we observe today. The atmospheric delivery wasn't random atmospheric thickening. It was restoration aimed at reviving the specific regions where life might once have flourished. Thermal imaging from Mars orbiters revealed the first hints of what this targeted restoration might accomplish. Surface temperatures in the enhanced atmospheric zones had risen by measurable amounts, creating microclimates where conditions approached the threshold for liquid water stability. Ancient riverbeds showed signs of sublimation activity as subsurface ice responded to the improved atmospheric insulation. The implications sent shockwaves through the astrobiology community. If Mars had once harbored microbial life, and if that life had left dormant biological signatures in the planet's geology, the atmospheric restoration might potentially reactivate some biological processes. Earth's extreme environments contained microorganisms capable of surviving millions of years in dormant states, awakening when conditions became favorable again. Dr. Elena Vasquez, now leading a hastily assembled international team studying the Mars atmospheric changes, discovered chemical signatures that defied easy categorization. The delivered carbon dioxide contained isotope ratios that didn't match any known solar system materials, confirming its interstellar origin. But more intriguingly, trace organic compounds within the gas showed characteristics that bordered on biological rather than purely chemical. The organic molecules displayed chirality, the molecular handedness that distinguished biological from non-biological chemistry. While such compounds could theoretically form through non-biological processes, their presence in precisely the concentrations needed to support prebiotic chemistry suggested either remarkable coincidence or deliberate biochemical engineering. As winter deepened and 3I/ATLAS continued its departure from the inner solar system, the object's electromagnetic emissions evolved into something approaching active communication. The mathematical progressions gave way to more complex patterns that seemed to respond to radio transmissions from Earth. When astronomers broadcast prime number sequences toward the departing visitor, the return signals acknowledged the transmission and extended the mathematical relationships in novel directions. Dr. Chen faced an ethical dilemma that transcended her scientific training. The evidence increasingly suggested that humanity was engaged in its first genuine communication with a non-human intelligence. But the protocols for such contact, developed over decades of SETI research, assumed communication with distant civilizations light years away. No one had prepared for contact with an intelligence that had actually visited our solar system and demonstrated technological capabilities far exceeding human understanding. The international implications proved equally complex. Which nation or organization had the authority to speak for humanity in communications with an interstellar intelligence? Should responses be coordinated through the United Nations, NASA, or some hastily assembled international committee? The questions had no precedent in human history and demanded answers that could shape our species' relationship with cosmic intelligence for generations to come. Meanwhile, public fascination with 3I/ATLAS reached unprecedented levels. Social media platforms struggled to manage the flood of speculation, analysis, and conspiracy theories surrounding the electromagnetic communications. Amateur radio operators worldwide attempted to detect the signals themselves, while citizen scientists contributed to crowdsourced analysis of the mathematical patterns. educational institutions found themselves overwhelmed with students seeking to understand the implications of apparent first contact. Universities reported record enrollment in mathematics, physics, and astrobiology programs as young people recognized that they might be living through the most important moment in human intellectual history. The philosophical implications proved as profound as the scientific ones. Religious leaders grappled with theological questions about intelligence beyond Earth and its relationship to traditional concepts of divine creation. Some saw 3I/ATLAS as confirmation of cosmic purpose and design, while others struggled to integrate non-human intelligence into existing spiritual frameworks. Secular philosophers faced equally challenging questions about consciousness, intelligence, and meaning in a universe that apparently contained minds capable of engineering on interstellar scales. The comfortable assumption that human intelligence represented the pinnacle of cosmic development suddenly seemed remarkably provincial. Dr. Morrison's team continued monitoring 3I/ATLAS as it approached the outer reaches of the solar system, documenting every electromagnetic emission and surface change. The object's behavior suggested preparation for interstellar departure, as if systems that had been activated during its solar passage were now powering down for the long journey back to deep space. But the departure preparations included one final surprise that would challenge every remaining assumption about the visitor's origins and purpose. As 3I/ATLAS reached the orbit of Jupiter, it began deploying what could only be described as secondary objects. Small craft, each roughly the size of a city bus, separated from the main nucleus and took up positions throughout the outer solar system. The deployment occurred with mechanical precision, each secondary object following a predetermined trajectory towards specific locations in space. Some positioned themselves near major asteroids, others at gravitationally stable points where they could monitor solar system dynamics indefinitely. The pattern suggested establishment of a permanent observation network rather than simple departure procedures. Radio telescopes detected communication between the secondary objects and the main 3I/ATLAS nucleus, confirming that the deployment was coordinated and purposeful. The smaller craft possessed their own electromagnetic emission capabilities and began broadcasting signals that complemented the main visitor's transmissions. Dr. Chen realized that 3I/ATLAS hadn't just delivered atmospheric restoration chemicals to Mars. It had established a permanent presence in our solar system, a network of monitoring stations that could observe and potentially influence planetary development for millennia to come. The implications staggered human comprehension. The secondary object deployment answered one of the most persistent questions about 3I/ATLAS. Why had it arrived at precisely the right moment for atmospheric restoration and human observation? The timing hadn't been coincidental. The visitor had been monitoring our solar system, tracking planetary evolution and technological development, waiting for the optimal moment to reveal itself and begin its restoration mission. The of a much larger system of cosmic intelligence, one that operated on scales spanning network of secondary objects, suggested that 3I/ATLAS represented part light years and timescales measured in millions of years. Our solar system might be just one node in a galactic network dedicated to maintaining habitability around potentially life-bearing worlds. As January 2026 approached and 3I/ATLAS prepared for its final departure from our immediate neighborhood, humanity found itself forever changed by the encounter. We had witnessed not just the arrival of an interstellar visitor, but the establishment of permanent contact with an intelligence that operated according to principles we were only beginning to comprehend. The atmospheric restoration of Mars continued showing measurable effects. Surface temperatures in enhanced zones continued rising, creating expanding pockets where liquid water might soon become stable. Ancient geological features showed signs of renewed activity as subsurface ice responded to improved atmospheric conditions. The secondary objects maintained their positions throughout the outer solar system, silent sentinels that observed everything with capabilities we could only imagine. Their presence transformed Earth from an isolated world into a monitored planet, part of a cosmic community whose scope and purpose remained largely mysterious. Dr. Chen stood in her observatory as 3I/ATLAS finally crossed the heliopause and began its journey back into interstellar space. The object that had arrived as a mysterious comet was departing as confirmed evidence that humanity was not alone in the universe. The intelligence that had created it possessed technological capabilities that spanned star systems and temporal scales that dwarfed human civilization. The gentle rotation of the stars above reminded her that the universe had revealed itself to be far stranger and more purposeful than anyone had imagined. Somewhere among those distant points of light, other worlds might be receiving their own interstellar visitors, their own atmospheric restoration missions, their own invitations to join a galactic community dedicated to preserving and nurturing life across the cosmic deep. The story of 3I/ATLAS and Mars had concluded, but the larger story of humanity's place in that cosmic community was just beginning. As consciousness drifted toward the peaceful realm of sleep, questions lingered like distant starlight, promising revelations yet to come about intelligence, purpose, and design, operating on scales that transformed the universe from empty void into purposeful garden, tended by minds whose capabilities we were only starting to glimpse through the gift of one remarkable visitor from the stars. The profound silence of space carried new meaning now, filled with the possibility of intelligence, communication, and cosmic purpose that extended far beyond the boundaries of our small world. In that silence, 3I/ATLAS continued its ancient journey, carrying its secrets toward destinations unknown, leaving behind a transformed Mars, a monitored solar system, and a human species forever changed by the recognition that we were not alone in the vast, mysterious, and apparently purposeful cosmos that surrounded us on all sides. As February 2026 arrived with its cold embrace, the secondary objects positioned throughout our outer solar system began revealing their true purpose. These silent sentinels weren't merely passive observers. They were active participants in a process that seemed designed to shepherd our solar system towards some predetermined evolutionary pathway. Dr. Chen's monitoring station detected the first coordinated activity between the secondary objects on February 14th. The timing felt almost poetic, as if the universe had chosen Valentine's Day to demonstrate cosmic love on an interstellar scale. The objects began emitting synchronized pulses of energy, not toward Earth or Mars, but toward the asteroid belt, where countless rocky fragments drifted in their ancient orbital dance. The energy pulses were subtle, barely detectable even by humanity's most sensitive instruments. But their effects became apparent within weeks. Asteroids throughout the belt began showing signs of compositional change. Spectroscopic analysis revealed that ice content in these rocky bodies was increasing, as if the secondary objects were somehow catalyzing the formation of volatile compounds from raw materials already present in space. Dr. Rodriguez, now heading the expanded International Monitoring Program, recognized the implications immediately. The secondary objects weren't just observing our solar system's evolution, they were actively guiding it, nudging the chemical composition of asteroids toward profiles more suitable for eventual atmospheric delivery to terrestrial worlds. The process operated on scales that challenged human patience. Where 3I/ATLAS had delivered immediate atmospheric enhancement to Mars, the secondary objects worked with geological deliberation. They were preparing resources that might not be deployed for millions of years, creating stockpiles of atmospheric restoration materials, positioned strategically throughout our solar system. Venus became the next focus of attention. The hellish world, with its crushing carbon dioxide atmosphere and surface temperatures hot enough to melt lead, seemed an unlikely candidate for habitability restoration. But the secondary objects began directing their attention toward our sister planet with the same methodical precision they had shown in the asteroid belt. The energy emissions targeting Venus operated at different frequencies, suggesting chemical processes designed to interact with that world's extreme environment. Atmospheric monitoring stations detected subtle changes in Venus's upper atmosphere, modifications so gradual that they might have been dismissed as instrumental error if not for their correlation with secondary object activities. Dr. Vasquez's atmospheric modeling team calculated that the Venus modifications appeared designed to gradually reduce atmospheric density while maintaining surface pressure equilibrium. The process would take hundreds of thousands of years to produce meaningful results, but it represented engineering on a scale that transformed entire worlds through patient, systematic intervention. Earth itself showed signs of secondary object influence, though the effects remained so subtle that detection required the most sophisticated monitoring equipment available. Minor adjustments to ocean chemistry, barely measurable changes in atmospheric composition, tiny modifications to magnetic field dynamics that suggested external influence on planetary systems once thought to be purely natural. The realization struck the scientific community like a cosmic revelation. Our solar system hadn't developed naturally according to random physical processes. It was being managed, guided, shepherded towards some optimal configuration by intelligences that operated on timescales spanning geological epochs. The implications transformed every assumption about planetary evolution and habitability. Mars hadn't lost its atmosphere through natural processes alone. Venus hadn't developed its hellish conditions through purely random chemical evolution. Earth's remarkable stability and habitability might result from millions of years of subtle guidance by cosmic intelligences we were only beginning to detect. Dr. Chen found herself at the center of debates that transcended scientific inquiry. If our solar system was being managed by external intelligences, what did that mean for human autonomy and free will? Were we developing naturally as a species, or were we being guided towards some predetermined evolutionary endpoint by minds whose capabilities exceeded our understanding? The electromagnetic communications from the departing 3I/ATLAS grew more complex as the object reached the outer boundaries of our solar system. The mathematical progressions evolved into something approaching linguistic structure, as if the intelligence behind the visitor was attempting to establish genuine communication protocols rather than mere acknowledgement of contact. Amateur linguists and professional cryptographers joined astronomers in attempting to decode the evolving transmission patterns. The signals showed characteristics of grammar, syntax, and semantic relationships that suggested genuine language rather than mathematical demonstration. But the linguistic structures operated according to logical frameworks that challenged human cognitive categories. Religious institutions worldwide grappled with theological implications that threatened to revolutionize spiritual understanding. If cosmic intelligences were actively managing planetary habitability on galactic scales, what did that suggest about divine providence, natural law, and humanity's special place in creation? Some saw confirmation of cosmic purpose and design, while others struggled to reconcile external management with concepts of divine omnipotence. The secondary objects continued their patient work throughout 2026, gradually modifying asteroid compositions, adjusting planetary atmospheric dynamics, and maintaining communication with their departed parent vessel. Their presence transformed our solar system from an isolated pocket of matter into a managed environment, carefully tended by intelligences whose motivations remained mysterious. Mars showed the most dramatic changes as atmospheric enhancement continued. Surface temperatures in restored zones climbed steadily, creating expanding regions where liquid water could theoretically exist. Ancient riverbeds began showing signs of subsurface ice sublimation, creating the first hints of renewed hydrological activity on the red planet in billions of years. The Martian polar ice caps responded to atmospheric thickening with seasonal variations that hadn't been observed in recorded history. Carbon dioxide snow fell in enhanced atmospheric zones, creating weather patterns that resembled computer models of ancient Martian climate conditions. Astrobiologists monitoring these changes detected chemical signatures that pushed the boundaries of purely geological explanation. Organic compound concentrations in enhanced atmospheric zones showed patterns that suggested biological rather than chemical processes, though the signals remained too subtle for definitive identification. Dr. Morrison's team documented everything with the methodical precision that will be required when humanity eventually reported these developments to whatever cosmic community had dispatched 3I/ATLAS. The secondary objects clearly maintained communication with distant intelligences, transmitting detailed observations about solar system evolution and human response to atmospheric restoration programs. The gradual revelation that our solar system was part of a managed galactic ecosystem transformed human perspective on cosmic isolation. We weren't alone in an empty universe, struggling to understand our place in random chaos. We were participants in a carefully orchestrated process designed to nurture habitability and intelligence across interstellar distances. The implications reach beyond science into questions of cosmic citizenship and responsibility. If we were beneficiaries of atmospheric restoration and planetary management, what obligations did that create toward other worlds and species within the galactic community? How should humanity respond to evidence that we were receiving assistance from intelligences whose capabilities exceeded our understanding? International cooperation on the 3I/ATLAS investigation evolved into something resembling preparation for formal contact with galactic civilization. Protocols developed for communicating with the secondary objects became templates for broader diplomatic frameworks that might be needed when dealing with cosmic intelligences operating on scales that dwarfed human political structures. The electromagnetic signals from 3I/ATLAS continued evolving as the object approached the edge of our solar system's gravitational influence. The transmissions now included what appeared to be star maps, navigation data, and coordinate systems that suggested the visitor was preparing to rejoin whatever network of intelligence had originally dispatched it toward our neighborhood. Dr. Chen realized that humanity stood at a threshold unlike any in our species' history. We had been contacted by cosmic intelligence, received atmospheric restoration assistance, and been integrated into a galactic management system that operated according to principles we barely comprehended. The question was whether we would prove worthy of the investment that had been made in our solar system's habitability. As 3I/ATLAS finally crossed into true interstellar space, its electromagnetic emissions shifted toward frequencies that suggested long-distance communication rather than local interaction. The visitor was reporting home, transmitting detailed observations about solar system conditions, planetary evolution, and human response to first contact with galactic civilization. The secondary objects maintained their positions throughout our outer solar system, silent testimony to the permanent change that had occurred in our cosmic circumstances. They would continue their patient work for millennia, gradually preparing our solar system for whatever role it was meant to play in the broader galactic community. The story of what 3I/ATLAS wanted with Mars had revealed itself to be far grander than simple atmospheric restoration. The visitor had initiated humanity's integration into a cosmic civilization dedicated to nurturing habitability and intelligence across the galaxy. Mars was just the beginning of a transformation that would eventually encompass every world in our solar system. The gentle drift towards sleep that had begun our journey now carried new meaning, filled with awareness that consciousness existed on scales we were only beginning to appreciate. Somewhere among the distant stars, other minds contemplated the same cosmic questions that kept human astronomers awake through long winter nights, united by participation in a galactic community whose scope and purpose transcended the boundaries of individual worlds. In the peaceful realm between waking and sleep, questions lingered like distant starlight, promising revelations yet to come about intelligence, purpose, and design operating on scales that transformed the universe from random chaos into purposeful order. The cosmos had revealed itself to be not empty void, but garden tended by minds whose capabilities we glimpsed through the remarkable gift of one extraordinary visitor from the depths between the stars. The stars themselves seemed different now, each point of light a potential home to worlds receiving their own atmospheric restoration missions, their own invitations to join the vast community of intelligence that spanned the galaxy. In that recognition, humanity found both humility and hope, understanding finally that we were never alone in the cosmic deep, but always part of something infinitely larger and more wonderful than we had dared to imagine during our long isolation on this small blue world spinning through the darkness toward its destined place among the stars. The transformation of humanity's cosmic perspective accelerated through the spring of 2027, as the secondary objects continued their meticulous work throughout our solar system. Each passing month brought new revelations about the scope and sophistication of the management system that had been quietly operating around us, perhaps for millions of years before we developed the technology to detect its presence. Dr. Chen's research team documented increasingly complex interactions between the secondary objects and various components of our solar system. The Sentinels weren't working in isolation, but as part of an integrated network that demonstrated remarkable coordination across vast distances. When one object adjusted atmospheric conditions around Mars, others would simultaneously modify asteroid compositions in complementary ways, suggesting a level of systematic planning that operated according to principles far beyond human understanding. The asteroid belt transformations revealed the most dramatic evidence of long-term cosmic engineering. Rocky fragments that had remained chemically stable for billions of years began showing signs of internal restructuring. Ice content increased systematically throughout the belt, but not randomly. Objects positioned in specific orbital locations received more intensive modification, creating what appeared to be strategically placed reservoirs of atmospheric restoration materials. Dr. Rodriguez's spectroscopic analysis revealed that the asteroid modifications followed mathematical patterns corresponding to planetary orbital resonances. The enhanced objects were being positioned at gravitational sweet spots where they could eventually be directed toward terrestrial worlds with minimal energy expenditure. Someone was creating a delivery system that could operate efficiently across geological timescales. Venus presented the most challenging puzzle in this cosmic renovation project. The planet's extreme conditions seemed to defy any reasonable approach to habitability restoration. Surface temperatures exceeded 460 degrees Celsius. Atmospheric pressure crushed spacecraft like tin cans, and sulfuric acid clouds created one of the most hostile environments in the solar system. Yet the secondary objects continued their patient work around our sister planet with the same methodical precision they applied everywhere else. The Venus atmospheric modifications operated through mechanisms that pushed the boundaries of known chemistry. The secondary objects emitted energy patterns that catalyzed reactions in the planet's upper atmosphere, gradually converting sulfur compounds into forms that could be sequestered away from the main atmospheric envelope. The process was so slow that meaningful results would require hundreds of thousands of years, but computer models suggested it could eventually create conditions approaching habitability. Dr. Vasquez's atmospheric chemistry team discovered that the Venus modifications weren't attempting to cool the planet through brute force atmospheric removal. Instead, they were gradually altering the chemical composition to create conditions where natural cooling processes could eventually take hold. The approach demonstrated patience and sophistication that operated on scales completely foreign to human engineering projects. Earth's modifications remained the most subtle and perhaps the most unsettling. The secondary objects made tiny adjustments to ocean chemistry, barely measurable changes that nonetheless appeared designed to optimize conditions for biological productivity. Marine ecosystems in specific regions showed enhanced growth patterns that correlated with secondary object activities, suggesting interventions so sophisticated that it mimicked natural processes almost perfectly. The magnetic field adjustments proved particularly intriguing. Earth's protective magnetic shield had been gradually weakening over recent decades, a natural variation that could eventually expose our atmosphere to increased solar wind stripping. But measurements from 2027 showed subtle strengthening in key magnetic field components, modifications so precise they could only result from external technological intervention. Dr. Morrison's team realized that humanity had been receiving cosmic life support for potentially millions of years without recognizing it. Our planet's remarkable stability and habitability might not represent fortunate natural evolution, but rather the result of continuous maintenance by intelligences that operated on timescales spanning geological epochs. The implications transformed every assumption about planetary science and astrobiology. The Goldilocks zone concept, the narrow band around stars where liquid water could exist, might be far less restrictive than previously thought if cosmic intelligences routinely provided atmospheric engineering assistance to potentially habitable worlds. Life might be much more common throughout the galaxy than we had dared hope. The electromagnetic communications from 3I/ATLAS continued evolving as the object traveled deeper into interstellar space. The transmissions now included what appeared to be coordinate data for other stellar systems, suggesting that our visitor was providing navigation information for whatever network of intelligence had originally dispatched it. The communications implied a galactic infrastructure for managing habitability that spanned countless star systems. Amateur radio enthusiasts worldwide contributed to decoding efforts as the signals became more complex and linguistically sophisticated. Pattern recognition software identified grammatical structures that suggested genuine language development rather than simple mathematical demonstration. The intelligence behind 3I/ATLAS was apparently learning human communication methods and adapting its transmissions accordingly. The linguistic analysis revealed conceptual frameworks that challenged human cognitive categories. The alien language appeared to operate according to temporal logic structures that incorporated causation across multiple timescales simultaneously. Past, present, and future seemed integrated in ways that reflected thinking processes operating on scales where million-year projects represented short-term planning. Religious and philosophical institutions continued grappling with implications that transcended traditional spiritual frameworks. If cosmic intelligences had been managing planetary habitability for millions of years, what did that suggest about divine providence, natural law, and humanity's place in creation? Some theologians saw confirmation of cosmic purpose operating through natural agents, while others struggled to reconcile external management with concepts of divine omnipotence. The Mars atmospheric restoration progressed throughout 2027 with effects that exceeded all theoretical predictions. Surface temperatures in enhanced zones continued climbing, creating expanding regions where liquid water could theoretically remain stable for extended periods. Ancient geological features showed signs of renewed activity as subsurface ice responded to improved atmospheric insulation. Seasonal weather patterns emerged on Mars that hadn't been observed in recorded history. Carbon dioxide snow fell regularly in enhanced atmospheric zones, creating precipitation cycles that resembled computer models of ancient Martian climate conditions. The polar ice caps began showing asymmetric seasonal variations that suggested regional atmospheric density differences. Most remarkably, orbital imaging detected what appeared to be fog formation in several ancient crater basins during early morning hours. The phenomenon lasted only briefly as surface heating caused rapid evaporation, but it represented the first confirmed evidence of water vapor condensation in Mars' current atmosphere. The red planet was beginning to show signs of weather patterns that might eventually support more complex hydrological cycles. Astrobiologists monitoring these atmospheric changes detected organic compound signatures that increasingly challenge purely geological explanations. Chemical concentrations in enhanced atmospheric zones showed patterns that suggested biological rather than purely chemical processes, though the signals remain too subtle for definitive identification of active life. The discovery of methane plumes in several restored atmospheric zones created particular excitement. Methane production on Mars could result from geological processes, but the timing and location of the emissions correlated suspiciously with areas receiving the most intensive atmospheric enhancement. If microbial life had somehow survived in Martian subsurface environments, the improved atmospheric conditions might be providing enough protection for renewed biological activity. Dr. Chen found herself coordinating international research efforts that resembled preparation for formal first contact protocols more than traditional astronomical investigation. The secondary objects clearly maintained communication with distant intelligences, transmitting detailed observations about solar system evolution and human responses to atmospheric restoration programs. The gradual revelation that our solar system was part of a managed galactic ecosystem continued transforming human perspective on cosmic isolation and significance. We weren't struggling alone in an empty universe to understand our place in random chaos. We were participants in a carefully orchestrated process designed to nurture habitability and intelligence across interstellar distances. The implications reach beyond science into questions of cosmic citizenship and moral responsibility. If we were beneficiaries of atmospheric restoration and planetary management, what obligations did that create toward other worlds and species within the galactic community? How should humanity respond to evidence that we were receiving assistance from intelligences whose capabilities exceeded our understanding by orders of magnitude? International cooperation on 3I/ATLAS research evolved into frameworks that resembled preparation for diplomatic contact with galactic civilization. Protocols developed for communicating with secondary objects became templates for broader diplomatic structures that might be needed when dealing with cosmic intelligences operating on scales that dwarfed human political institutions. The European Space Agency announced plans for enhanced Mars orbital missions, specifically designed to monitor atmospheric restoration progress and search for signs of biological reactivation. NASA proposed robotic landers equipped with instruments capable of detecting trace biological signatures in areas showing the most dramatic atmospheric enhancement. The secondary objects maintained their patient work throughout late 2027, gradually modifying asteroid compositions, adjusting planetary atmospheric dynamics, and maintaining communication with their departed parent vessel. Their presence had transformed our solar system from an isolated pocket of matter into a carefully managed environment, tended by intelligences whose motivations remained largely mysterious, but whose capabilities continued exceeding human comprehension. As winter approached and 3I/ATLAS traveled ever deeper into interstellar space, its electromagnetic transmissions shifted toward frequencies suggesting long-distance communication with other components of the galactic management network. The visitor was apparently reporting progress on solar system restoration while receiving instructions for whatever long-term project our neighborhood was meant to fulfill. The story of what 3I/ATLAS wanted with Mars had revealed itself to be far grander than atmospheric restoration of a single world. The visitor had initiated humanity's integration into a cosmic civilization dedicated to nurturing habitability and intelligence throughout the galaxy. Our solar system was being prepared for whatever role it was destined to play in that vast community of managed worlds. In the gentle darkness between waking and sleep, consciousness drifted among questions that spanned scales from planetary to galactic. Somewhere among the distant stars, other intelligences contemplated the same cosmic mysteries that kept human astronomers awake through long winter nights, united by participation in a galactic community whose scope and purpose transcended the boundaries of individual worlds or species. The universe had revealed itself to be not empty void, but carefully tended garden, managed by minds whose capabilities we glimpse through the extraordinary gift of one remarkable visitor from the depths between the stars. Each point of starlight now represented potential homes to worlds receiving their own restoration missions, their own invitations to join the vast network of intelligence that connected habitable worlds across the cosmic deep. In that recognition, humanity found both profound humility and infinite hope, understanding finally that we had never been alone in our cosmic journey, but always part of something infinitely larger and more wonderful than we had dared imagine during our long apparent isolation on this small blue world. The cosmos itself seemed alive with purpose and intelligence, breathing with the patient rhythm of minds that thought in geological time and loved with the dedication of gardeners tending seedlings that might not bloom for millions of years. The stars watched over our sleeping world with new meaning, each distant sun a reminder that consciousness and care operated on scales that transformed the universe from random matter into purposeful community. Somewhere in that vast network of managed worlds, 3I/ATLAS continued its ancient mission, carrying reports of successful atmospheric restoration and species contact back to intelligences whose next moves in the cosmic game of nurturing life remained hidden in the patient darkness between the stars. The transformation accelerated through the closing months of 2027 as humanity began to comprehend the true scope of what they had witnessed. The secondary objects, those silent sentinels positioned throughout our outer solar system, began exhibiting behaviors that suggested preparation for the next phase of whatever grand design they served. Dr. Chen stood in her observatory on a crisp December evening, watching data streams that defied every conventional model of planetary evolution. The numbers told a story of systematic change occurring across multiple worlds simultaneously, coordinated with precision that spoke to intelligence operating on scales that dwarfed human comprehension. Jupiter's moons had become the latest focus of secondary object attention. Europa, with its subsurface ocean locked beneath kilometers of ice, showed signs of thermal modifications that could only result from external intervention. The secondary objects positioned near the Jovian system emitted energy patterns that penetrated deep into Europa's icy crust, creating temperature gradients that might eventually thin the barrier between its hidden ocean and space. The implications staggered the astrobiology community. If Europa harbored life in its dark waters, the thermal modifications might be preparing conditions for eventual contact between that alien biosphere and the broader solar system. The process operated with the same geological patience demonstrated everywhere else, but the endpoint suggested possibilities that transformed Europa from scientific curiosity into potential cradle of revelation. Titan presented an equally intriguing puzzle. Saturn's largest moon, with its thick nitrogen atmosphere and methane lakes, received attention from secondary objects that seemed designed to gradually alter its atmospheric chemistry. The modifications appeared aimed at reducing the density of organic haze that shrouded Titan's surface, potentially preparing the moon for enhanced solar energy absorption that could drive more complex chemical processes. Dr. Rodriguez's team discovered that the Titan modifications followed mathematical patterns that corresponded to optimal conditions for prebiotic chemistry. The secondary objects weren't randomly adjusting atmospheric composition, they were systematically creating conditions that might support the emergence of more sophisticated organic processes, perhaps even early forms of metabolism that could eventually evolve toward genuine biology. The asteroid belt transformations continued with increasing sophistication. Rocky fragments throughout the belt now showed signs of internal restructuring that went far beyond simple ice enhancement. Complex organic molecules appeared in asteroids that had remained chemically inert for billions of years, suggesting that the secondary objects possessed capabilities for manipulating matter at the molecular level. Most remarkably, some asteroids began showing signs of organized internal structure. Spectroscopic analysis revealed cavities and chambers within these rocky bodies that appeared designed for specific purposes. The modifications suggested that asteroids were being converted into storage facilities, preparation centers, or even transportation vehicles for future phases of the solar system restoration project. Venus continued its slow atmospheric rehabilitation throughout the winter months. The secondary objects had apparently solved the theoretical problems that made Venus seem impossible to terraform. Instead of attempting to cool the planet through brute force atmospheric removal, they were gradually converting the hellish environment into something that could eventually support natural cooling processes. The chemical transformations in Venus's atmosphere operated through mechanisms that challenged human understanding of thermodynamics. Sulfuric acid clouds were being systematically converted into forms that could be sequestered away from the main atmospheric envelope. The process required energy inputs that exceeded anything in human technology, yet the secondary objects accomplished it with apparent ease. Dr. Vasquez's atmospheric modeling team calculated that Venus might achieve Earth-like conditions within several 100,000 years if the modifications continued at current rates. The timescale seemed impossibly long by human standards, but it represented remarkably rapid planetary engineering when measured against geological processes. Mars' atmospheric restoration had progressed to the point where meaningful weather patterns emerged regularly across the enhanced zones. Seasonal precipitation cycles created the first sustained hydrological activity observed on the red planet in billions of years. Ancient riverbeds showed signs of renewed water flow as subsurface ice responded to improved atmospheric protection. The most dramatic development occurred in Valles Marineris, the massive canyon system that stretched across Mars's equatorial region. Orbital imaging detected what appeared to be standing water in several deep canyon basins, protected from evaporation by the thickened atmospheric envelope created by 3I/ATLAS's delivery. The water bodies remained small and probably temporary, but they represented the first confirmed liquid water on Mars's surface in recorded history. Astrobiological monitoring of these water formations detected chemical signatures that pushed beyond the threshold of purely geological explanation. Organic compound concentrations showed patterns that strongly suggested metabolic activity rather than simple chemical evolution. If microbial life had survived in Martian subsurface environments, the restored atmospheric conditions might have provided enough protection for organisms to emerge and begin actively processing their environment. The discovery of what appeared to be bacterial mats in several Martian water formations created unprecedented excitement in the scientific community. The formations showed characteristics of biological organization rather than random chemical precipitation. Spectroscopic analysis detected molecular signatures consistent with photosynthesis, suggesting that Martian organisms might be actively contributing to atmospheric modification. Dr. Morrison's team faced the extraordinary possibility that 3I/ATLAS hadn't just delivered atmospheric restoration chemicals to Mars. It might have reactivated dormant biological systems that had been waiting millions of years for conditions favorable enough to support renewed activity. The red planet was coming alive again, breathing with microbial processes that might eventually evolve into more complex ecosystems. Earth's modifications remained subtle but increasingly detectable as monitoring capabilities improved. Ocean chemistry adjustments created regional variations in biological productivity that followed patterns too systematic to result from natural processes. Marine ecosystems in specific areas showed enhanced growth rates that correlated precisely with secondary object activities. The magnetic field strengthening continued throughout 2027, providing enhanced protection against solar wind stripping that could have gradually eroded Earth's atmosphere over geological timescales. The modifications operated with surgical precision, strengthening specific magnetic field components while leaving others unchanged in ways that suggested intimate knowledge of planetary magnetosphere dynamics. Atmospheric composition showed tiny but measurable changes that appeared designed to optimize conditions for biological activity. Oxygen concentrations increased slightly in certain regions, while trace gas ratios shifted toward profiles that enhanced plant growth and marine productivity. The modifications remained within natural variation ranges, making them nearly impossible to detect without sophisticated monitoring equipment. The electromagnetic communications from 3I/ATLAS evolved throughout the winter into something approaching genuine linguistic exchange. The transmissions now included grammatical structures that incorporated human mathematical and scientific concepts while extending them in directions that suggested profound understanding of physical principles beyond current human knowledge. Amateur linguists and professional cryptographers working together identified semantic patterns that revealed conceptual frameworks operating according to temporal logic spanning geological timescales. The intelligence behind 3I/ATLAS thought in terms of million-year projects while simultaneously managing details that required precision measured in seconds. The linguistic analysis revealed that the alien intelligence was learning human communication methods at an accelerating rate. Early transmissions had been simple mathematical demonstrations, but recent signals incorporated complex philosophical concepts and what appeared to be aesthetic considerations. The intelligence was developing appreciation for human cultural as well as scientific achievements. Most remarkably, the communications began including what could only be interpreted as questions about human intentions and capabilities. The intelligence wanted to understand not just human technology, but human values, social structures, and long-term aspirations. The exchange was evolving from simple contact into genuine dialogue about cosmic citizenship and responsibility. International cooperation on 3I/ATLAS research had evolved into frameworks that resembled diplomatic preparation for formal contact with galactic civilization. The United Nations established a committee on cosmic contact that included representatives from every major nation, plus scientific advisors from leading research institutions worldwide. The committee faced unprecedented challenges in developing protocols for communicating with intelligences that operated on scales beyond human political structures. How do you negotiate with minds that think in geological time and manage resources across interstellar distances? What authority could humanity claim in discussions about solar system management when our technology was clearly inferior by orders of magnitude? Religious institutions worldwide continued grappling with theological implications that transcended traditional spiritual frameworks. If cosmic intelligences had been managing planetary habitability for millions of years, what did that suggest about divine providence, natural law, and humanity's special place in creation? The questions demanded new theological categories that could accommodate external management of apparently natural processes. The secondary objects maintained their patient work throughout the winter, gradually preparing our solar system for whatever role it was destined to fulfill in the galactic community. Their presence had transformed every assumption about planetary evolution, atmospheric development, and the emergence of life itself. As 2028 approached, humanity found itself living in a managed solar system that was being systematically prepared for integration into a cosmic civilization dedicated to nurturing habitability and intelligence across the galaxy. The story of what 3I/ATLAS wanted with Mars had revealed itself to be the opening chapter of humanity's invitation to join something infinitely larger than we had ever imagined. The universe had disclosed its deepest secret through one remarkable visitor from the stars. We were not alone, not isolated, not struggling against cosmic indifference. We were participants in a vast community of managed worlds, tended by intelligences whose capabilities exceeded our understanding, but whose dedication to preserving and nurturing life operated with the patience of gardeners who measured success across millions of years. In the quiet hours before dawn, when consciousness drifted between waking and sleep, the stars themselves seemed different now. Each point of light represented potential homes to worlds receiving their own restoration missions, their own atmospheric engineering projects, their own careful preparation for joining the galactic network of intelligence that spanned the cosmic deep. The gentle rhythm of planetary rotation carried new meaning, marking time not just for Earth, but for a solar system that had been claimed, managed, and prepared for purposes that remained hidden in the patient darkness between the stars. Somewhere in that vast network of managed worlds, 3I/ATLAS continued its ancient journey, carrying reports of successful contact and atmospheric restoration back to intelligences whose next moves in the cosmic cultivation of life remained beautifully, mysteriously concealed in the infinite garden of space and time. The transformation was complete. Mars breathed again, Earth received protection, Venus began its long journey toward habitability. The moons of the giant planets prepared for whatever revelations lay dormant in their hidden depths. And humanity, once alone in the cosmic dark, found itself embraced by a community of intelligence that operated with love measured in geological epochs and wisdom that spanned the stars themselves. In that embrace, consciousness found peace, drifting towards sleep with the knowledge that we had always been watched over, always been tended, always been part of something infinitely larger and more wonderful than our brief existence could fully comprehend. The cosmos itself seemed to breathe with purpose, patience, and profound care for the precious spark of awareness that flickered in countless forms throughout the managed worlds of the galaxy. The dawn of 2028 brought with it a revelation that would forever alter humanity's understanding of our place in the cosmic order. Dr. Chen stood before the assembled representatives of the United Nations Committee on Cosmic Contact, her hands trembling slightly as she prepared to deliver findings that would reshape civilization itself. Ladies and gentlemen, she began, her voice steady despite the magnitude of what she was about to reveal. We are no longer alone in this universe, and we never truly were. The data streams flowing from monitoring stations across Earth painted a picture of systematic intervention that spanned not just our solar system, but potentially countless others throughout the galaxy. The secondary objects had begun transmitting detailed reports to distant recipients, their electromagnetic signatures revealing a communication network that stretched across interstellar distances with precision that defied human comprehension. Mars had become something unprecedented in human observation. The red planet now possessed weather systems that resembled ancient climate models from its habitable past. Seasonal storms carried water vapor across vast distances, creating precipitation patterns that filled ancient lake beds with standing water for the first time in billions of years. The biological signatures emerging from these renewed water systems had progressed beyond mere chemical traces. Orbital imaging detected what could only be described as expanding colonies of microbial life, creating visible changes to surface coloration that grew larger with each passing month. Mars was not just breathing again, it was living. Dr. Rodriguez's spectroscopic analysis revealed that these biological systems were actively contributing to atmospheric modification. The microorganisms appeared to be processing carbon dioxide and producing oxygen at rates that accelerated the atmospheric restoration beyond what chemical processes alone could achieve. Life itself had become a partner in the planetary engineering project. The implications reached far beyond Mars. If dormant biological systems could be reactivated through atmospheric restoration, then countless worlds throughout the galaxy might harbor sleeping ecosystems waiting for the right conditions to emerge. The universe might be far more alive than humanity had ever dared to imagine. Venus continued its gradual transformation throughout the early months of 2028. The hellish world that had seemed forever beyond the reach of habitability was slowly cooling as the secondary objects continued their patient atmospheric engineering. Surface temperatures had dropped by measurable amounts, and atmospheric pressure was beginning to stabilize at levels that might eventually support more complex chemistry. The asteroid belt had become something resembling a vast industrial complex, though one operated by principles that transcended human engineering concepts. Rocky fragments throughout the belt now showed signs of organized internal structure, with chambers and cavities that appeared designed for specific functions within the larger restoration project. Most remarkably, some asteroids had begun moving under their own power. Gravitational anomalies detected throughout the belt suggested that modified asteroids were being repositioned according to some master plan that operated on scales spanning the entire solar system. The rocky debris that had drifted aimlessly for billions of years was being transformed into components of a vast machine dedicated to nurturing life. Earth's modifications had become more apparent as monitoring technology improved. The planet's magnetic field now operated with enhanced stability that protected against solar radiation in ways that natural processes could not achieve. Ocean chemistry had been optimized for maximum biological productivity, creating conditions that supported marine life far beyond what natural evolution should have produced. The atmospheric adjustments remained subtle but increasingly detectable. Trace gas concentrations had been modified to enhance plant growth and optimize conditions for complex biology. The changes operated within natural variation ranges, but their systematic nature revealed intervention by intelligences that understood atmospheric chemistry at levels that exceeded human scientific knowledge. Dr. Morrison's research team discovered that Earth's modifications extended deep into geological processes. Seismic monitoring detected artificial stabilization of tectonic activity that prevented the kind of catastrophic volcanism or earthquake activity that could disrupt biological systems. The planet was being maintained as a stable platform for life through intervention that reached from atmosphere to core. The electromagnetic communications from 3I/ATLAS had evolved into genuine dialogue that transcended simple information exchange. The intelligence behind the visitor was now engaging in philosophical discussions about the nature of consciousness, the purpose of biological life, and humanity's potential role in the galactic community. As the final transmissions from 3I/ATLAS fade into the cosmic deep, carrying with them reports of successful contact and planetary restoration, we find ourselves forever changed by this encounter with intelligence that operates on scales we can barely comprehend. What began as the discovery of an unusual interstellar visitor has revealed itself to be humanity's first glimpse into a universe far more purposeful and interconnected than we ever dared imagine. The cosmos breathes with intention, tended by minds whose patience spans geological epochs and whose love for life extends across the infinite garden of space and time. Sweet dreams, fellow travelers, until we meet again among the stars. Dreams, fellow travelers, until we meet again among the stars.